So now we are going to discussing about problems on Ohm's law. Okay. So coming to the problem here. So a resistance of 10 ohms is connected to across a supply of 100 volts. Okay. Which varies in steps of 10 volts from 0 to 100 volts. Calculate the corresponding current for each step of voltage and also draw the graph by assuming voltage on x-axis and current on y-axis. Okay, so this is the problem will be given like this. Okay, so these models are very important, so based on Ohm's law. Okay, so coming to the here, first of all one resistance is given. Okay, I have to write the given data here. So given data is, okay, so here the resistance will be given 10 ohms. Okay, first of all I have to draw the one resistance here. So like this we have to represent it. Okay, so this resistance value is like 10 ohms. Okay, so and also is connected across a supply of 100 volts. Okay, means this resistance which is connected across the 100 volts battery. Okay, so that can be we have to represent it like this. Okay, so this is the 10 volts battery, means simply we have to represent it like this. Already know that the symbol of battery indication. Okay, so this is the representation of battery. Okay, like this. Okay, which varies in steps of 10 volts from 0 to 100 volts. Okay, here means this 10 volt supply which will be varying from 0 to 100 volts. Okay, 0 to 100 volts means here, so that is like either 0 volts, like 10 volts, like 20 volts, like 30 volts, like 40 volts, like that. So up to 100 volts this voltage will be gradually increasing. Okay, means this voltage is gradually rising up to 100 volts. Okay, here given like this. And also so the calculate the corresponding current for each step of voltage. Okay, here number of voltage ratings will be coming like this. So at each voltage, okay, at each voltage we have to calculate to the corresponding currents we have to calculate it here. Okay, so that is the given problem according to from the data. Okay, first of all we have to calculate to the, so each voltage, at each individual voltage we have to calculate into the individual currents here first of all. Okay, so coming to the here, first of all we have to representing on voltage here, we have to take into the voltage ratings here, and also we have to take into the like resistance also here, and also so total current. Okay, so total how much amount of current will be, so finally we are getting, so that current also we are getting here. So current in terms of amperes also we have to draw here. Okay, coming to the voltage, first of all we have to take the 0 volts. First of all we have to take the 0 volts here. Okay, and also at the 0 volts what is the resistance will be given here, so that is generally given as 10 ohms. Okay, at 0 volts we have to represent it to the 10 ohms. Okay, at that condition what is the total current we are getting, so according to Ohm's law already know that I is equal to V by R. According to Ohm's law I is equal to V by R. So from this V is equal to IR. Okay, so from this finally what we are getting value, so that is given as I is equal to 0 by 10 ohms, 0 by 10 ohms. So finally we can get to the, so 0, so that is the 0 amperes. Okay, so and also next one, for example if you want to go for like a 10 volts. Okay, why, because here the voltage will be varying from one value to another value up to 100 volts. Okay, so at 10 volts here also what is the resistance, here resistance value is fixed, already know that. Okay, so that is given as I is equal to, so 10 by 10 that is given as 1 ampere, that is given as 1 ampere, ampere or amperes. Okay, and next we are going to 20 volts, at 20 volts. Okay, so at 20 volts, so what is the resistance, here also 10 ohm resistance. Okay, finally we are getting I is equal to V by R, so that is given as 20 by 10, so that is given as 2 amperes. Okay, that is given as 2 amperes. Next at 30 volts, here also like 10 ohm resistance. Okay, so that is given as 30 by 10, that is the value is given as 3 amperes. Okay. So up to we have to calculate it like this 100 volts. Okay. At 40 volts, so here also 10 ohm resistance is there. So that is given as 40 by 10. Okay. So that is given as 4 amperes. At 50 volts, here also we are getting 50 by 10, that is given as 5 amperes. Okay. At 60 volts, here also we are getting at 10 ohm resistance, that is given as I is equal to V by R, that is given as 60 by 10, that is given as 6 amperes. Okay. At 70 volts, here also we are getting 70 by 10. So like this we have to calculate into the all those total current at the voltage at the different types of voltage ratings. At the different types of voltage ratings we have to calculate into the all those currents here. Okay. So that is given as 7 amperes also here. At 80 volts, here also resistance 10 ohms. So that is given as 80 by 10. Okay, that is given as 8 amperes. At 90 volts, here also like 10 ohm resistance. Okay, so that is given as 90 by 10, that is given as 9 amperes. Okay, like this way to represent it to the all those values. Okay, at last one is the at 100 volts. So last one is the 100 volts. Here also here resistance is fixed. Why? Because the total resistance will be given here 10 ohms. So that's why we have to resistance is the fixed here, that is given as total 100 by 10 ohms, that is given as finally 10 amperes. So like this we have to calculate into the at all different types of voltage ratings. Finally we are getting like 1 amperes, 2 amperes and 3 amperes and 4 amperes and 5 amperes and 6, 7, 8, 9 up to 10 amperes we are getting like this. So according to these all current values, now we have to draw the current versus voltage graphs. Okay. So here x-axis taken as a voltage and y-axis taken as a current. Okay. So between voltage and current, now we have to draw the finally graph. First of all, we have to represent into the total voltage rating here, and also here represent it into the total voltage on x-axis like 0 volts and 10 volts and 20 and 30 and 40 and 50 and 60 and 70 and 80 and 90 and 100. So like this we have to represent it to the total voltage and also current also. Now we have to represent it. So first of all we are getting, so what is the minimum value? So from that we have to like that we have to represent it here. So like 1 ampere and 2 amperes and 3 amperes and 4 amperes and 5 amperes and 6 amperes and 7 amperes and 8 amperes and 9 amperes and 10 amperes. Why? Because here maximum we are getting to the 10 amperes currents. So that's why in that graph we are representing up to 10 amperes only. And also here voltage also maximum is the 100 volts. So that's why we are maximum voltage we have to draw the on the x-axis like up to 100 volts. Okay. So coming to the here at 10 volts we are getting basically 1 ampere. Okay. So that's why we are getting like this we have to represent it. So this is the 1 point. Okay. And also at 20 volts we are getting 2 amperes current. So that's why at 20 volts we are getting 2 amperes. That's why we are getting, this is the point. Okay, final point. And also at 30 volts we are getting 3 amperes. So that's why we have to representing like this at 30 volts. Okay. So all those points we have to representing like this, and only we are getting to the like a linear type motion we are getting to the graph here. Okay. At 40 volts and 4 amperes between we are getting 1 point here. Okay. And also at 50 volts and 5 amperes between 1 point is intersected here. So that point can be, we have to represent it like this. And also at 60 volts all those points clear cut we are learning here. At 60 volts between the 60 volts and 6 amperes we are getting point here, so that point also represent here. And also at 70 volts and 7 amperes also we are getting like this point, okay, intersected. So at 80 volts and 80 amperes currents between, if you want to intersect those 2 points, so finally we can get into the this point. And also at 90 volts 9 amperes current, if you want to intersect those 2 points, so finally we can get into the this point also we are getting. And also at 100 volts and 10 amperes currents, if you want to intersect those 2 points, so finally we can get into the these points, okay. So if you are observe the overall entire diagram, if you want to intersect all those points, so finally we can get into the linear nature like this curve will be coming, okay. So this curve will be generally we are getting according to the giving data of Ohm's law, okay. So I think you understood what I am saying, okay. For the next class we are going to discussing about different various types of problems on Ohm's law, okay. So thank you one and all, thank you.